Every year, landslides, avalanches, and other types of mass movements results in fatalities. These types of natural hazards are of significant concern throughout the world. In particular, for the research we're doing in this lab, we're looking at the movement of snow avalanches downslope and maximum runouts. This translates very nicely to the Hawaii world, where we have issues with landslides. So in looking at this from a model perspective, we are taking digital elevation models, terrain models, and coupling that with particles that move downslope. Based on a training set of data that we have from a known area, we are able to model the flow downslope and determine maximum runouts. From these maximum runouts, we can apply this to other areas and predict where we might have avalanche flow. The nice thing about these types of models is that they can be applied for many types of mass movements. Whether it's avalanches or landslides, these can be applied and modeled for the environment that they're appropriate to. For areas where landslides and avalanche are a risk, decision support models can be helpful in determining where areas may be of higher hazard. So in looking at examples from different places in the world, we can build decision support models that determine and detect where sensitive slopes, sensitive sites such as houses, pipelines, transportation networks may be at risk from these types of mass movement events. There are many types of different models to use depending upon the type of hazard that we are investigating. In one case, we can actually look at expert-based models. So these models take into account the experts' advice and knowledge of an area for many years. So many experts have a very intimate knowledge of the landscape, the environment, and the hazard, and are able to translate that into a model that we can create an algorithm from and actually look at taking that knowledge from the expert and applying it in a computer environment. This may be similar to what we would have in a Hawaiian example as far as cultural knowledge of an area. So by being able to take that information, the cultural knowledge of the area, we can incorporate that into an algorithm and apply that to our model and adjust accordingly.